still in 2.2, we want to find all points. Points are ordered pairs, x comma y's, where the graph of a function has horizontal tangents. Okay, so a horizontal tangent would be a horizontal line. And what is the slope of a horizontal line?
X over 0.
Horizontal line has a slope of 0.
Oh, horizontal.
Isn't this horizontal?
Yeah.
Horizontal line, slope is 0. So in other words, they're asking you where the slope is 0. What ordered pairs does the function have a slope of 0? So they're saying slope, where is slope equal to 0? That whole set of directions is just asking you that simple question right there. Where is the slope equal 0? Well, what's another word for slope?
Derivative.
Okay, so where is derivative equal to 0? So whenever they ask you to find horizontal tangents, where is the derivative equal to 0? That's all they're asking. Where is a tangent line a horizontal line? Visually, here's what it looks like. Here's what it looks like visually. I'm going to do it on a separate sheet real fast. Visually, a place where a function would have a horizontal tangent could happen lots of places in some functions. It happens lots of times in this function. It happens here. Wouldn't that tangent be horizontal?
Yeah.
And right here, and right here, and right here. Do you know what those points are referred to as?
P. Yeah, I think P. Is it a climax?
Max and mins. Maximums and minimums. Highest and lowest points. Peaks and valleys. Peaks and valleys. Okay, so do you know exactly how many places there should be a horizontal tangent in a function? Like if I have a function that's f of x equals x squared. Well, what's x squared look like? A parabola. How many max and mins does that have? 1. Okay. Do you always have to have a max or a min? No, because here's an example of a function, y equals 1 over x. This is what the graph of 1 over x looks like. Does that have maximums or minimums anywhere? No, it does not. So some of your questions, some of the problems we do will have no horizontal tangents. You might come up with none for an answer here. So let me go back to the problem, or to the directions here. To find all points where the graph of a function has a horizontal tangent, you take the derivative, you set it equal to 0, and you solve it. So where is the derivative equal to 0? The directions. 1, find y prime. 2, set it equal to 0. And 3, solve for x. That's how you find where the horizontal tangents are. Then 4th, find the y values. Because you need points or ordered pairs. Okay, so let's take a look at a really easy example first. So example 1, find where this function y equals negative 3x squared plus 4. I would not want to be the student he was talking to right now. I would not want to be. Okay. So.
Yeah, I'd hope we would behave a little better than that.
So find y prime. So in order to find the place where this function has a horizontal tangent line, we find the derivative. So y prime is multiply by 2. What do you get in front? Negative 6. Take 1 away from the power, it becomes x to the first. And the derivative of a number is 0. So there's my derivative. Then what do I do next? So there's step 1. Step 2, I'm going to set my derivative equal to 0. Step 3, I'm going to get x by itself. So how am I going to get x by itself?
Divide by 6.
Divide both sides by -6, and x equals 0. What is the y value that would go with 0? Where would you put 0?
Oh, in the x. So
In the original equation, put 0 in the original equation, and you get 4. So they're saying 0, 4 is where there is a horizontal tangent. In other words, this is where the max or min is. This is where the max or minimum is. I should actually know that this parabola opens which way, up or down?
should open.
Down, because of the negative in front of x squared. And its vertex is at 1, 2, 3, 0, 4. That's the vertex, the max or min is the vertex in a parabola. So that's the place where it has a horizontal tangent. Do you have to do the graphing thing? No. I'm just visually trying to show you what it looks like. Okay, let's look at a second example of finding the place where a function has a horizontal tangent. How about f of x equals x plus cosine of x? How about our function f of x is x plus cosine of x? Where does that have a horizontal tangent? All right, so what do we do? Horizontal tangent.
Derivative.
Find the derivative. So what's the derivative of x? 1. The derivative of cosine? Minus sine of x. So we find the derivative. Now what do I do with it? Set it equal to 0. How would I start to get x by itself here? Minus, could I add sine of x?
No.
Would that eliminate a whole step? Add sine of x, so I have basically 1 equals the sine of x. So now how do you get rid of the sine? What's the inverse operation to get rid of the sine? Do you remember arc sine, inverse sine? That's how you get rid of the sine. So technically I'm taking the inverse sine of both sides. So the inverse sine of the sine is x, and x is the angle whose sine is 1. The way you read the inverse sine of 1 is the angle whose sine is 1. So we need to go on our unit circle. Here's how you do that. On our unit circle, sorry, it's not sine, S-I-G-N, it's S-I-N-E. The angle whose sine is 1. So go on your unit circle, you've got all these ordered pairs, right? Which value is the sine? X or Y? Y. So you're going to look, where is the Y value, positive 1, and find the angle that goes with it. So you have unit circles. So go to your unit circle. Here's your unit circle. Look at the Y values. I see there's 1. Isn't that 1 in the Y value? What is the angle? No. Pi over 2. Do not give me degrees in calculus. I would understand you, but a college professor may not like it so well. They give you a 0 on the whole thing. So pi over 2 is the place where the sine is 1. So x equals pi over 2. Okay, so how do you get the y value then? Because you need an ordered pair.
Plug it in.
Okay, to get y, plug into f of x. So f of x was x plus cosine of x. So f of pi over 2 plus cosine of pi over 2. Cosine is the x value, isn't it?
0.
So that's 0. So pi over 2 plus 0 is pi over 2. So what is the horizontal tangent? Horizontal tangent at the ordered pair, what? What was the x value? Pi over 2. And the y value is pi over 2. So that's the place where it's going to have a horizontal tangent. What? Well, there technically would be more than one, but like in your book, they just say between 0 and 2 pi. So you only look once around, and there is only one place here in this one. There might be two if it were like a tangent pi, is equal to 1. There would be two. You're absolutely right. So what they give you in the homework is they say, they basically say only look between 0 and 2 pi. That's what that means. Only look around the unit circle one time. So, all right. So your homework, if I can find, here's the page. I've adjusted your homework, so please look. We're on homework number 23 right here. I can solve the tangent line problem and find where a function has horizontal tangents. That's what the new thing I added. And really that's all you're doing. On page 115, you're doing 53 through 62 all. That's a little bit of both. And on page 104, cross everything out that I have from page 104 typed up and do 25 through 32 all instead. This is one assignment from 2 different pages. This is not 2 assignments. One assignment from 2 different pages. They're all the same types of problems. So go ahead and get started. I have